So apparently, while I'm fixing my own technical things, I've somehow removed my cool Auburn background. I'm trying to fix it. Now I've got my nifty timer up. As a disclaimer, every time you guys log in, if you do not want to end up on YouTube later, you've got to turn off your video. Other than that, you might have your little picture on the YouTubes. Everyone is automatically muted. If you want to speak, you can look for your settings. There's going to be a button you can push to unmute yourself every time you want to say something. Or you can just send me chat messages, like privately or publicly, for like, hey, can you try something? If you have a problem from either the assignments or con lesson that you wanted specifically to ask me about, just get a screenshot and email it to me. Meanwhile, I'm going to keep trying to figure out how I put my cool Auburn background back up.
Yeah.
One, two, three, four, 5, 6, 7, 8, 9, 10. A few more people. If we get a few more people, we will be setting, I guess, a new record for how many log in for a live session. Keep in mind, if you guys have to go, everything's all good because the recording will go up on YouTube later. I know people's schedules can be kind of upsy downsy these days. I wonder if the option to do my cool background got taken away. I switched over my Zoom account to align with TCBOE, and maybe that was like an option that used to exist that doesn't exist anymore. It's really strange. I think it was called a dynamic background. If anyone can figure out where that is in the next 7 minutes and 2 seconds, that'd be sweet.
They just kicked me out of the meeting.
Dun, dun.
They kicked me out, bro.
Just going through Zoom settings.
Okay, there we go. I'm unmuted.
I know I can hear you, bro. No, you can't share that.
If you are literally sitting here waiting for us to get started and you got nothing better to do,
Bro,
ask yourself, have I made my bed today? And if you haven't, you probably should. Every good day starts with a made bed. Okay, so apparently what I'm looking for is the virtual background. Did I find it? Apparently I go to my account, settings, then what? In media advanced. Nice card virtual background. Okay. So settings. Virtual background. Okay, flipped it on. Now what? About 4.5 minutes. If you got a specific problem you want to see worked out, go start looking for it. Now you can either type it to me or send me a picture. Sweet. I need like 15 monitors because I got so many windows open. We look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep. This is looking to be the highest live attendance so far, which is a good sign in the first week that we get that make that happen. I'm sorry about yesterday. I'm constructing a new computer, and I was hoping it would be up and running, and it just was not. Now, still, I'm back on my old computer today, but I put all the pieces back that I needed to make live sessions work. Okay, so that 3 minutes, and we're gonna start working on problems. Still trying to see if I can get my virtual background to work. Well, the weather was kind of mucky yesterday, but I'm hoping everybody has had a chance to get outside. The shelter in place does allow for people to go outside and run around. You just can't get into big groups, and you keep your distance. So when the weather is nice, I hope everyone's getting outside and running around. There we go.
Hit the three, bruh.
One minute and counting. I'm gonna check emails for screenshots. Unless otherwise, I'm gonna start picking problems myself. Maybe it won't let me do the virtual background while the meeting is going. Maybe I have to do it beforehand. Who knows? Who knows? Yeah, it should be right here in my window. It's just not. Okay. So I'll just be broadcasting my room. Okay. Get rid of that. Apparently, there is also a whiteboard function that I really need to find. See if I can dig that up as well. But for everyone that is here, welcome, welcome, welcome. Today we're going to be talking about more practice with exponents, which will include all kinds of different exponent laws and calculations. Um, for anyone that was not here or didn't watch the previously recorded video, quick disclaimer: if you are broadcasting your video and you don't want to end up on YouTube later, like you might see a small thumbnail or something,
Oh, you're
then you
silly,
just turn off your video option. You can just listen and watch. You don't have to broadcast yourself. If you want to talk, all you have to do is hit the button to unmute yourself and speak, or you can type in the chat window and I will see it. The another disclaimer about, I'm just checking emails while. Okay. I was just asking if the Zoom meeting was canceled. It is not. We are here. Okay. So the difference between an assignment and practice. I've given you a whole bunch of con lessons to practice this week. The assignments that I'm going to grade are in Classroom on the assignment tab. Those are PDF files that you can edit or post your own, like Google Doc or something with your work and answers on it. I'm going to start looking at those today so that maybe if you've turned them in ahead of time, which they are due Friday, if you turn them ahead of time, I can look them over and maybe send you back some suggestions as problems you want to try again before you act. Like maybe you can unsubmit, resubmit with different answers, that sort of thing. So that's the difference between a graded assignment, which are posted in the Classroom tab, the classwork tab on Classroom, and just practice problems, which are just the myriad of lessons I've posted on Khan for everybody. Okay. I'll see if I can find the whiteboard later and obviously fix my virtual background. But at this time, since I don't see any emails or chat messages or text messages or any other messages with a specific problem you guys want help with, we are going to get started right here with exponents with integer bases. Okay. So this is where I'm going to need you guys to start chiming in if, for whatever reason, you're having a hard time seeing what I am writing or typing, like if the Zoom isn't good enough or something's not clear. So here we go. Da, da, da. Yeah, so I'm changing the option for annotation, and I thought I flipped it off where you guys couldn't draw on screen because that was a problem because we couldn't tell who was drawing what. But I'm not even seeing my annotation options. 1 second. I mean, I can just copy and paste this in the pane, do it that way. That'll be my go-to if I don't find annotations. Yep, I guess that's what I'm going to do. Okay.
I can hear y'all, bro.
All right, so if you don't have your paper and pencils ready, let's get going. Okay. Let's try to make this as easy to read as possible. Yep, that's a good one. Okay. So this problem right here, this is -2 raised to the 5th power, but there are two very different problems that this could have been. This says -2 to the 5th power. What it does not say, it is not -2 in parentheses to the 5th power. Those are two very, very different things. So when you see this kind of a problem, you have to remember that this negative symbol is not connected to that exponent whatsoever. What this really is -1 times 2 to the 5th power. So we're going to go ahead and solve 2 to the 5th power first, and then just make it negative. So I already know my answer is going to be negative something. So now all we have to discern is what is 2 to the 5th power. Well, that's 1 times 2 5 times. That's 1, 2, 3, 4, 5. That's 5 times. So, okay, so 1 times 2 is 2, times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Just double check that. Okay, so that's all right. One to what's 1, 2. Why is my pen? Why not changing color? There we go. All right, so that's 1, 2, 3, 4, 5. 1 times 2 is 2, 4, 8, 16. Yeah, it looks right. To the 5th, to the 1st, to the 2nd, to the 3rd, to the 4th. All right, so this would be negative. So then we have to multiply the -1 times that. So our answer would be -32. Not saying it's going to change much, but if it were this other problem, it would have been -2 5 times. That would have been 1 times -2 repeated over and over and over again. So that's the big takeaway. If you don't see parentheses, that means you're going to take whatever the power is and just make it negative at the very end. Okay, let's try another one. Oh yeah, I got to put in my answer. So that'd be, what would we say, -32. Sweet. Again, if you guys want to go peek at the assignments I posted on Classroom and browse that real quick and go, oh, Mr. Matthews, I really want to see one like number whatever on assignment 1, I am more than happy to give you specific examples, because right now, if you aren't asking me, hey, I want to see more like this, I'm just going to start going through the lessons and find problems that I'm hoping you can learn from. Okay, so there are a couple lessons having to do with this in particular. That's not what I wanted. Copy. Okay, so now what we got going on is in parentheses. So this is, come on, doing the brush. Here we go. All right, so this is a little different from our last one because they actually put the value in parentheses. So this is -1 to the third power. Okay, so sidebar here. This is really important for understanding whether your answers come out positive or negative on a bunch of levels because of the exponent. So this particular exponent, 3, is an odd number. And that's going to be really important for an abstract rule that I'm about to explain. Okay, so let's say this had been any negative number, -5, -10, any negative value. When I see that it's got an odd exponent, I know that my answer will be negative. Let's talk about why that is. So this is going to be 1 times -1 3 times. So that's 1 times a -1 times a -1 times another -1. So that's 3 of them. Okay. So now we've got to think back to 7th grade integer rules. When you multiply two negatives together, you get positive. If you multiply a positive number and a negative number together, you get a negative answer. So with this, even with this little -1, -1, you got to keep that in mind. Okay, so 1 times -1 is -1. But the moment you multiply that by another -1, now we're back to +1. And then we multiplied it by another -1. So now we're back to negative. So here's what happened. Because this is an odd exponent, we end up with an odd number of negatives, which means that every 2 will make a positive because negative times negative is a positive number. But then at the very end, you've got one more negative number. So this is going to be -1 for our answer. But I said I'd explain the abstract rule. So let's just say this had been, change up the color a little bit. So let's say this has been -1 to any even number. It could be 2, 6, a million. As long as it's even, those -1s would always pair up and make a positive by multiplying. So -1 times -1 is 1. -1 times -1 is 1, that sort of thing. So if it's an even, doesn't matter how big it is, I know this is going to come out to be a +1. And that is an abstract rule that you're going to be quizzed on a lot. And it's not rigorous. And the other thing is a calculator won't be able to help you, most likely, if they give you some bizarro bonkers large number. So to put that in perspective, if they were to give you, like, let's say -1 in parentheses, that's important, -1 to the 75th power, since that's odd, that's going to be -1. If you were to be given -1 in parentheses raised to the 124th power, because it's even, I know that'd be equal to 1. And that's the abstract rule. Okay. That should have given people enough time to go look at those assignments and see if there's one like, oh, Mr. Matthews, can you show us one like number such and such? But no one has said anything in chat that I know of. Let's see if chat's even working. Thank you, Takes. All right, so people have the option to say, but I will go ahead and keep checking my email just in case someone sent me one. If you don't want to raise, like, there's literally a raise your hand tool in this, and if you don't want to do that, you can actually instead of sending chat to everyone, you can send it just to me, so no one even has to know that you're the one that asked me which one to show. But okay, so no email. Let's see. Oh, cool. No, I didn't get a question, but someone did just send me a picture of their assignment, which is awesome. Okay, so I'll look at hers later. But okay, we'll move right along then. So what we say, this is going to be -1. Okay, so -2 raised to the second power. Yeah, so this one, I can actually use the column tool. I'm not sure how easy this will be for you guys to read, but so this is -2 raised to the second power. But again, there's no parentheses. So in this case, the negative, I just already know my answer is going to be negative because what they need me to do, like I'm going to solve whatever this is and then just make it negative. So 2 times 2, that'd be 1 times 2 twice. So 2 times 2 is 4, so this would be -4. -10 to the second power, aha. Now they put this one in parentheses, so this would be the same as 1 times -10 times -10 because they put it in the parentheses. So that would be now negative times negative, positive. Remember I said if it's an even exponent, that means that this will end up being a positive answer. This is going to be positive 100. -3 to the third. Okay, no parentheses this time, which means I already know my answer is going to be negative. All I need to do is solve whatever 3 to the third power is. So that'd be 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, so this would be -27. And this is how fast your column lessons should be going for practice once you get the hang of them. -2 to the third, no parentheses. So it'd be -2. Back that up. There are no parentheses. So I know my answer is going to be negative. This is like a -1 times 2 to the third. So I already know my answer is going to be negative. So 2 times 2 times 2, that'd be 2 times 2 is 4, times 2 is 8. So I'd say the answer is -8. Next question, -3 in parentheses. Okay, now quiz yourself right now. This is -3 to the fourth power. It's an even exponent. Will our answer be positive or negative? Yep. Since it's an even, that means it'll be a positive answer. So this is going to be, man, that is rough. I can do better than that. All right, so 3 to the fourth power. I usually like to chunk mine a little bit. Instead of me thinking of this as 3, 4 times, I'm going to do this like 9 times 9 because it comes out to be the same. So it should be just positive 81. Woohoo! Okay, I'm looking. When did you send it? Did you send it via email or text message or what? I'm not seeing it. Can you? So the person just asked me about a problem via email. Can you resend it? Because I am not seeing it. Maybe it's just taking forever, but I don't know. Last question from this lesson. Okay, this is not in parentheses, so I already know my answer is going to be negative. So that's me -1 times 9 squared. So this is where someone might say, hey, Mr. Matthews, you said if there was an even exponent that my answer is supposed to be positive. Hang on. What I said was if your base, that means it's -9, if that was in parentheses, that would really change the question around. Yeah, if it had been -9 in parentheses raised to an even power, totally agree, it would come out even. But this is not that. This is -1 times whatever 9 squared is. So this is going to be -81 simply because they didn't nest the base in parentheses. Bada bing, bing, bing. I just realized I had computer sound muted for some reason. Let me change that. Oh, speaker's muted, but my mic shouldn't be muted. My mic is working, right? That'd be really silly for me to have been on for like half an hour and have nothing recorded. Hey, Javion, how's it going? Okay, so I guess my mic is definitely working then. I guess part of the process of moving my computer around, somehow I muted my computer and I can't change that at the moment. Who knows? Who knows? Okay, I'm still not seeing anything in my inbox, so let's go on to the next lesson. Okay, so the integer laws apply to fractions as well. Here, you guys tell me. I can just use the con tool if you guys can read it. I just don't want it to get so small you guys can't see it. So can everyone read what I'm writing? When I like, if I were to rewrite this right now in this pen, so this would be -5 to the third, raise the second power. Is that too small? Okay, so Tate says he can see it fine. Anybody else want to chime in? I don't know if anyone's trying to watch on a phone, but there's not much I can do about that. Okay, okay, well then I'll just keep using the actual con tool and not have to go bouncing back and forth between copying and pasting. Technology is fun. Okay, so they did nest this one in parentheses, so I know it's going to be a positive answer, but this kind of dips back to your sixth grade fraction skills. What is 5/3 being raised to the second power mean? Okay, well, that does not change. This is going to be -5/3 times itself twice. -5/3 times -5/3. Okay, so top times top and bottom times bottom. So 5 times 5 is 25. Hey, Diana. 5 times 5 is 25, and 3 times 3 is 9. For those of you just joining us, if you don't want to end up on YouTube, all you have to do is deactivate your actual video, and that way you can see me, hear me, and chat along, but you don't have to show your face if you don't want to. So this should be 25/9. Make sure on con, when you're typing in your answer, you're using the front slash, the one that leans forward. That means we read left to right, so forward means to the right. Sweet, 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 sweet. Oh, cool. Yeah, okay. So I'm going to pause here from just plucking problems. I'm going to do one that was submitted via email. Very exciting. Okay, so here is the problem. If you got paper and pencil, which I would hope everyone has, uh, what a dream. Even at home, everyone has their own paper and pencil. Okay, so here's the problem that was submitted via email that everyone should be trying. So it says to evaluate, and it says -3 2/3 in parentheses raised to the second power. Okay, I'll give you a hint. The first thing you want to do is take this mixed number and turn it into an improper fraction. So I'll give you a small head start. Answering an email while you guys work that out. It is an email from a student, not just randomness. Okay, so most of you should have had time to try this one out. So here's what you would do. Again, now if you're super rusty on turning mixed numbers and improper fractions. Here's a small tutorial. So I understand it's gonna be negative. So 3 2/3. The longest way to think about this on paper would be to say, okay, well, this is 3 whole numbers. So that means that would be 3/3 plus 3/3 plus 3/3. So there's my 3 whole numbers, 1, 2, 3. And then I'd have this 2/3 left. So that would be 3, 6, 9, 11. So that'd be 11, negative 11 thirds. All being raised to the second power. So since you don't want to take all the time in the world to do this every time, there is a shortcut. So the way you turn a mixed number into an improper fraction quickly, and this is just a pattern some mathematician realized works every time. What's 3 times 3? Well, 3 times 3 is 9. If you add 2, you get the 11. So 3 times 3 is 9 plus 2 is 11. You leave the denominator the same. So essentially, you're multiplying the 3 times because that's how many whole numbers you would have had, and repeated addition is multiplication, and then you just add the fraction onto the back. So that being taken care of, we really haven't solved the problem yet. So that being said, come on, brush. Here we go. So that means this is 1 times negative 11 thirds 2 times. So 11 times 11 is 121. Now this is negative times a negative, so we'll end up with a positive answer. So that'd be 121 over 3 times 3 is 9. On the off chance that this is a completely valid answer, that means it's correct, but if your con lesson is telling you not quite, that means they just want you to simplify. Let's see, 121. Actually, no, never mind. 121 can't be divided by 3. That's a little divisibility rule. The integers have to add up to a multiple of 3. So 1, 2, and 1 add up to be 4. So I know I can't divide that by 3. So no, I'm pretty sure this is just going to be as good as it's going to get. Okay. So let me check. Anybody else send me a picture? Anyone something? You can't because it'll be a decimal. You mean just doing the 11 divided by 3? Oh, I get it. I get it. I get it. Yeah, yeah, yeah. Well, okay. Well, I get. Okay, so here's a question, and this is sort of off topic, but it's a good little teach. We call this a teachable moment, and if I had another whiteboard, I would just jump to it. So here's. Wait, well, go away. Okay. So here's the question. Okay. If a fraction comes out to be a decimal, does that mean it can't be simplified? Okay, so that's the question that just popped into my head, and we'll move on to our normal stuff here in a second. But if a fraction comes out to be a decimal, I mean it can't be simplified. Okay, so I'm gonna try to think. So I'm gonna reason it. I'm gonna construct my argument. These are math practice standards, which I should have. Hang on. My brain is turning the math. Oh, come on. So many windows. Let me capture my 8 math practice standards real quick. This was so much easier when I had them on the board behind me. Okay, so those are the math practice standards. I don't want to make them too blurry by zooming in too much. Okay, so what am I doing right now? That. Okay. If a fraction comes out to be a decimal, does that mean it can't be simplified? So, um, hmm. Okay. Well, I am going to construct an argument. I'm going to say, okay, well, first I want to make up my own example. So, like, let's say, hmm, 12 eighths. Okay. So I've made a fraction, and I'm almost positive if you put that in a calculator, it's going to come out to be a decimal, right? 12 divided by 8. Definitely comes out to be a decimal. Okay, so I'm modeling my mathematics. Let's see, I just used a calculator, so that would be an appropriate tool. Where's the tool? That's 5. So I used an appropriate tool. Okay. So does that mean that it can't be simplified if it comes out to be a decimal? I'm going to argue no, because these can both be divided by 4. So that'd be 3 over 2. Okay, so I guess just in this little tangent of ours, if you ever end up with a fraction and you put it in a calculator and it comes out to be a decimal, and you're like, oh, well, if it comes out to be a decimal, that means it can't be simplified. I would disagree with you. I would disagree with you. I think sometimes they can come out to be decimals and also be able to be simplified. So from now on, I'm going to try and use that knowledge every time I get a fraction just because it comes out to be a decimal. Does not mean it's in simplest form. Okay, well, that was fun. Hey, Morgan, how's it going? If you're just joining us, just and you don't want to end up with your little picture on YouTube, just close down your video function and you can watch and listen and not end up on the YouTubes. All right, I'm going to keep checking for classroom and private messages. If you guys have any questions about a problem from the assignments that are posted on Classroom, that's on the classwork tab, and you're like, hey, Mr. Matthews, I don't know how to do number 7 or whatever, just say so. I'm broadcasting for another 20 minutes or so. So we got 20 minutes for me to either pick problems or for you guys to pick problems. So let's see. Okay, going back to this. All right, so just because it gives me a negative fraction, I'm not going to be too worried about that. This is actually really similar to the one we just did. So -1 and 1/4, all raised to the second power. Oh yeah, and you guys are automatically muted when you join the meeting, but if you want to unmute yourself so you can ask me a question orally, then just unmute yourself and blurt it out. Okay, so this one, okay, the first thing I'm going to do with this is I'm going to turn it into an improper fraction, the fast way that I just showed you. So this is the same. Okay, so 4 times 1 is 4, plus 1, that'd be 5. So that'd be -5/4 raised to the second power. Okay, so now I can use my exponent rules. This is going to be 1 times -5/4 twice. Running out of room. Okay, so since it's an even exponent, I know that this negative times negative is going to come out to be a positive answer. So we just do top times top. So that'd be 25. Front slash bottom times bottom, which would be 16. Should be good. Huzzah. -1/2. Now, fortunately, you guys might start to be able to do these in your head. Um, the rule is if it's an odd exponent when you've got a negative base, that means you're going to end up with a negative answer. I already know it's going to be negative. 1 to the 5th power is 1. Is 1 times 1 times 1 forever. 2 to the 5th. Now, that part I actually need to think about. 2 to the 5th power. Could be 2 times 2 times 2. Let's write that out. So it'll be 1 times 2, 5 times. 1, 2, 3, 4, 5. Okay. So 1 times 2 is 2, times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it's going to be negative 1 over 32. Negative 3 and 1/3 raised to the second power. I think that's the one we just did, if I'm not mistaken. Nah, I already cleared it away. So that would be negative. No, it's different because there was a 2 on top. So that'd be negative 10, negative 10 thirds raised to the second power. 3 times 3 is 9, plus 1 is 10. Yep. Negative 10 raised to the third power. Okay. So. It's going to be positive answer because even exponent. So 10 times 10 is 100. And 3 times 3 is 9. So, sweet. Huzzah. Checking to see if anyone emailed me a question or sent me a private message. Nope. No one's asked me specifically about another problem, so I will just go and pick one. Oh yeah, these are fun. Okay, I'm gonna say these are fun, and then you're gonna immediately argue with me. But these are more logic, really thinking problems. So, like, awesome. So they said b to the 53rd power, and someone on the other end of CMAS is gonna have a heart attack. But really, let's focus on what they're asking. They're asking for the sign. All you have to do is tell them whether it's gonna be positive, negative, or zero. Okay. So the first thing you want to do on these is look at the number line and decide what are these things worth. You'll notice A is actually on 0 on the number line. So guess how easy this problem becomes if you were thinking A to the 14th. A is 0. 0 14 times is still 0. And 0 times all this other stuff, it's not going to matter. 0 times all that is just nothing. Hooray. So before you hit the panic button because you see a 14th power and a 53rd power and a fraction and two variables and whatever, anything times 0 is 0. Okay, so here, we got a 73rd power and a decimal panic mode. No, don't worry about it. So all we have to do is decide the sign. That means it's either going to be positive or it's going to be negative. That's all we're trying to figure out. Okay, so we just talked about an abstract rule a few minutes ago about the even and odd. Okay, so right now, hopefully you guys can answer this. Is 73 even or odd? Oh, Jay Young's trying to butter me up. We all love math. The answer, oh, yeah, you got it. So chime in the chat, and if you haven't found your chat function, go ahead and find it, guys. Is 73 odd or even? Okay. Yay, Luger's awake. Broken brilliant. Okay, we all agree. So I'm pretty sure you all know that that's not a number, but I just want to make sure everyone had their chat function working. Uh, okay. So if 73 is odd, that means that this whole term, okay, the negative 3, if we're doing that 73 times, for every 2 times you do the negative values, that'll make a positive sum, not positive sum, product. We're multiplying. So negative 3 times negative 3 is a positive number. So if there's an odd number, it's going to be this. I mean, the number is going to be so big it won't even fit on your calculator, but we know that it's going to be a negative value. Let me change the code on that. We know that it's going to be negative. So divided by, okay. Now this one, there's no math to do. It's already negative. So simply go back to your 7th grade integer rules. If you are ever multiplying or dividing two negative numbers, you get a positive answer. If you're ever multiplying two negative numbers together or dividing two negative numbers together, the answer is positive. So you don't have to worry. Don't panic when you see, oh yeah, we've got a fraction and a fourth power and an inequality. Don't worry about it. All we're trying to do is figure out if it's going to be positive or negative in the end. Okay. So let's break this down. Okay.
So we gotta do all of this.
I know it wants us to find a sign, which means it wants us to figure out. Sorry, I got distracted. I got an email for a problem to do, but I think it's the exact same problem I've already done. So the person that just emailed me a picture of a problem, I think I've already done that one. You might have meant to send a different picture. Okay. So let's break this down. What does this mean? If we've got, I don't want to, okay. When it says A is less than 0, that just means that A is negative. When it says A is less than 0, that just means that A is negative. Okay. So let's take that knowledge and think about this exponent. A to the fourth power. Okay, it goes back to that rule. This is an even number. 4 is even. So if we're doing negative, if A is negative and we're raising it to the fourth power, the rule is whenever you're multiplying any negative base to an even exponent, that answer is going to come out positive. And that's all we wanted to take away from that. We're not really trying to figure out what the number is. So that means that we have a positive value being divided by a positive value. And then we've got this negative symbol. Okay, so positive divided by positive is just positive, and it's being made negative by this negative symbol. So the answer will be negative. A to the fourth, no matter what A is going to be a positive value. So divided by 3, it will come out to be a decimal or a whole number, but it will be a positive decimal or a whole number. And since it's being made negative by this guy, we're just going to say negative. 10-minute warning, everybody. We got 10 minutes left on today's live stream. So if you have a specific question from the classwork assignments or something from a different con lesson and you want to screenshot it, or just, hey, Mr. Matthews, can you please work out one that's like number 7 on our assignment 2? You need to get it to me in the next couple minutes. Otherwise, it'll have to wait till tomorrow. Could you do number 3 from lesson 1? Sure, man. So in case you guys haven't even seen the assignments because reasons, let's see, first period. I'm just going to borrow first period's class time. Okay. So classwork. So I believe the question was number 3 from lesson 1.
How do we?
So here's assignment 1. 8 people have turned it in, which means 8 people might get some feedback and get a chance to fix their answers. Problem 3. Okay, so I can't actually work this exact problem out, but I'll make one up that's very similar. Number 3 from lesson 1. Okay, so let's screen capture that real quick. Hang on. Let me grab that. Copy it. All right. I think if I make this too big, it's going to get really fuzzy, so let me rewrite that. All right, so here's the request. It's parentheses 2 raised to the negative 7th times 5 to the 5th. And then that's all raised to the second power. Let me double check. And it gives us, okay, it's not actually asking for, okay, I got it, okay. So this question is not actually asking you to punch this into a calculator and get some complicated answer. It's asking whether or not you understand the laws of exponents. So while I'm not going to solve this exact one, let me make one up that's really similar to explain what's happening. So let's say we're using the wrong tool. Let's say we have, I don't know, 5. There's a 5 in that one. Let's say 4 to the third power times 6 to the negative 10th power, all being raised to the third. Okay. Even if this had been variables, the laws would still apply. So you know what I'm actually going to do? I'm going to take these guys and I'm going to make it a little more abstract so you guys aren't focusing on like just trying to punch in values. So if I were to gut out the 4 and the 6 and just plug in, okay, let's just say it's m to the third times g to the negative 10th. Okay, anything can be in there. This is powers of powers, basically. So a simpler version of this would be something like x squared in parentheses raised to the 4th power. Now, here's the abstract law. When you're doing like an exponential expression raised to another power, you can multiply those two powers together. So this would be the same as the x to the 2 times 4th. So that'd be x to the 8th. Now, the difference between this abstract rule and this is that our red problem here is a binomial. There are two things. So what you end up doing, you apply this to both terms. It's the same rule as down here. We just have to do it to two different things. So this should come out to be something like m to the 9th times g to the negative 30th. I'm going to see if I can prove that in another way. Move my little abstract law out of the way. Yikes. Okay, so if I were so inclined and I wanted to really think this out, I would be doing this whole base 3 times. So that would be m to the 3rd times g to the negative 10th times m to the 3rd times g to the negative 10th. And at this point, you're probably realizing why we made up the quick rule, because we are lazy and doing all this is a lot. This would be, so I needed it 3 times. So it'd be m to the 3rd times g to the negative 10th. Okay. So all the m's I got, I use a different color. So I've got m to the 3rd, m to the 3rd, m to the 3rd. And another one of our abstract rules is that when you are multiplying exponential expressions with the same base, you can add their exponents. So like x squared times x to the 5th would be x to the 7th. So that's the abstract rule. So this would be 3, 6, 9. So that's where the 9 comes from. And then negative 10, negative 20, negative 30. That's where the negative 30 comes from. Okay, so on the original question, what you'll end up doing is taking this power and you'll be doing powers of powers with both terms. Okay, I hope that's helpful. So anybody else got a question from the assignments? So going into tomorrow with the last 3 minutes, if you want to go ahead and submit your assignments today, I can take a look at them and probably give you some insight into the problems you might want to try again. So let's say Johnny turns in his assignments tonight and Mr. Matthews sees them and Mr. Matthews notices that Johnny missed numbers, I don't know, 5, 6, and 7. And then he messages Johnny saying, hey, listen, before Friday, you might want to try out numbers 5, 6, and 7 again. That is only possible if Johnny turns in the assignment. So check out Classroom, submit your work. I'll try to get back to you in time for you to fix some answers before Friday. But if you want to roll those dice and just turn it in on Friday, hoping that you are just golden and you didn't miss anything, that's fine. That is up to you. They are due by Friday. And let's see, is there anything else coming up? Um, the Zoom Tech seems to have been easier to use today. I did link up my account with the TCOBOE affiliate, so that probably made logging a little bit easier. Yes, Javion. So the answer is every day. The plan is to do this every day from 10 to 11 for eighth grade math students. If I have technical difficulties, I'll post on Classroom like I did yesterday. That snappy sound is my bottle. Um, yeah, yesterday I was moving. I'm building a new computer, and when I was moving my parts around, I couldn't get everything set up back in time because my new computer isn't working just yet. Still waiting for one more part. That But no, the plan is to do a live stream from 10 to 11 every day. So if you cannot make it though, as soon as I close this, I download the video, save the video, upload the video to YouTube. So for if you guys just had a thing or you couldn't get your wireless to work or whatever, you can watch the live stream later on my YouTube channel, which is also linked on Classroom. I think that's all the business. So I hope you guys are doing well. Stay safe, stay healthy. Try to get outside if you can. But take care of your family, take care of business, and be good people, all right? And I'm serious. Go make your beds. If you didn't, it makes for every day. Every good day starts with a made bed. I'm a believer. Miss you guys. See you next time.